I'm okay. I got scared. And I panicked. Okay, so anyway, opposite over hypotenuse. Well, let's go to this capital B or beta and label the opposite. The opposite is, we don't have it. It's supposed to be 3. The hypotenuse is, we don't have it. It's supposed to be up here. The adjacent, ooh, okay, we have it. It's 8. Okay. Unfortunately, we cannot put this 8 up in this little fraction because 8 is the adjacent. Darn. Well, let's maybe mess around with the Pythagorean theorem. Let's say a squared plus b squared equals c squared. Only instead of using the 12 and the 16 like we did for this left triangle, I'm going to use the OG 3 and 5. Okay, so the hypotenuse is the C. The opposite is the B. We don't know the adjacent, so let's keep a letter A. And then let's figure this out. Okay, this makes a squared plus 9 equals 25. 25 minus 9 is 16. Square root of 16 is 4. Okay, so that does not mean the adjacent is 4. It means the reduced adjacent is 4. So the question is, how did we get from 4 to the 8 on this right-hand triangle? So we used the original, or we used the reduced opposite and hypotenuse, and we put it in the Pythagorean theorem. And we got the reduced adjacent side. But we don't want to know the reduced side. We want to know after you've multiplied or whatever. So this is the reduced side, adjacent, 4. And I want to know what times that 4 gives me this adjacent of an 8. And it should be the number 2. That's what we're going to be multiplying by. So remember over here on step 1, we figured out the multiplier real easy. This time, it was hard to figure out the multiplier. So the multiplier is 2. So let's go back up to this 3 over 5 and O over H. And we're going to multiply by 2. 3 times 2 is 6. 5 times 2 is 10. That's the opposite and the adjacent of this right-hand triangle. So the opposite is 10. The opposite is 6. And the hypotenuse is 10. Yeah. Okay, so that opposite that we just labeled, BE, is 6. And we just labeled DB is 10. And we only have one more. Okay, so the last thing to do is this kind of janky tilted triangle. We want to find out what AB is. Okay, so for that triangle, we already have 2 pieces. Yeah. So this is my 4th step. I'm going to go mess with that triangle. That crooked triangle already had 2 pieces. Its base was 10. Its height was 20. Let's figure out its hypotenuse. A squared plus b squared equals c squared. So we get 20 squared plus 10 squared equals c squared. And I think that's 500 equals c squared. But when you try and take a square root of that, it doesn't work because it's not perfect. So I want the answer with a square root still in it. I do not want a decimal. So let's try and break up that 500. 500 is 25 times, oh gosh, 20. 20 is 4 and 5. 4 is 2 and 2. 25 is 5 and 5. Okay, let's cross out what we have broken. Find the pairs. 2, 5. Those go on the outside. Find the single lady. 5. She goes on the inside. Okay, so on the out, we're going to have 5, 2. On the inside, we're going to have this single 5. But that looks kind of janky. It looks like 52. So let's multiply it. And we're going to have c equals 5 times 2. 10, square root 5. And this makes sense. Remember when we were doing this one in class, Jonas pointed out that that last answer was a square root, but everything else was pretty and perfect and whole. So yay! So AB is 10 square root 5. Ah! And you can do these steps out of order, but you still got to do them. All right, let's look at number 7. It says draw in standard position. Well, 0 is over here on the right, 90 is up above, 180 is here. So standard position starts at the positive and goes all the way around to like maybe ish here, 200. And then draw a diagonal. Yeah. Okay, that was probably too far in, but as long as you're close enough, I'll be okay. Okay, let's look at negative 132. Oh no. 0 is still where he always is, but 90 is now downstairs and it's negative. 180 is in the same spot, but it's negative. 270 is now upstairs and it's negative. So negatives, the graph gets flipped upside down. Okay, so let's figure out where negative 132 is. We start at that 0 and we go around, we go past negative 90 and yeah, sure, it's somewhere around here, I think. Doesn't have to be perfect. Hey, there you go. We drew negative 132. It goes down and around. 455, we're not going to do that one. And we're not going to do the 14 pi over 9. And we're not going to do the negative 28 over 9. We didn't have time to learn those. You could probably figure it out. If you want to know, 455 goes around once, because that's 360. And then it goes around some extra. And we'd have to find the extra. So if I subtracted off 360, this will give me like 95 or something. So 450 is all the way around once for 360 plus 95. So this guy would land right up here. But you don't have to know that. So these 3, you don't have to know how to do. I'll teach it to you eventually. Okay, negative 90, we know where that is. We start at 0, down to negative 90. Hey, only when we draw the diagonal line for negative 90, it's not diagonal, it's just straight up and down. All right, let's keep going. It says convert from degrees to radians. Every time you see the word convert, you need to think about, what am I trying to make go away? This degree symbol. So that means you need to put the degree symbol in the bottom. Okay, and when we convert from degrees to radians, you multiply by pi over 180. You might want to write that on your cheat sheet. Then you do 155 divided by 180, math, enter, enter. And you could try and reduce it in your face, If you try and reduce this in your face, please check using the calculator, just because sometimes our faces do weird things on test days. Okay, so this turns into 31 over 36, and now let's slap a pi on top. Yeah. Okay, the second one says convert from radians to degrees. So we're going backwards. You're going to multiply by 180 over pi. And if we forgot that, like whether 180 should go on the top or the bottom, let's remember that whatever you want to go away has to go in the bottom. So I want this pi to cancel out. So it has to go in the bottom so that it'll cancel out. And then pi is worth 180, so I put 180 on the top. Okay, now we're going to do 17 times 180 divided by 18. And look at the directions. It says no decimals. So make sure you press math enter. And we get 17 divided by 180. Sorry. 17 times 180 divided by 18 equals 170. So this turns into 170 degrees. Woohoo! Hey, on this top guy, see how it says convert from degrees to radians? Scratch out this part that says round to 4 places. My bad. Yeah, so don't round to 4 places on that first guy. I think I got confused when I typed this up. Okay, the last one, it says convert from decimal degrees to degrees, minutes, seconds using your calculator. Okay, this is where we have to type in 42.328, then second. No, is it? Yeah, second. Apps. And then DMS. This is kind of what we did today. And Angelina told us that we don't have to put the little circle in the air when we type it. So let's go. 42.338 second. Apps is underneath XT theta, blah, blah, blah. It's right here. Apps. Okay, then we're going to go down to number 4. Or just press 4 and enter. And we have 42 degrees, 19 tick mark. That means minutes. And 40.8 double tick mark. That means seconds. Okay, number 9 and 10 we didn't get to, so we're scratching them out. Or, my bad, just number 9. But there's 2 pieces to number 9. We'll learn that another day. Okay, number 10. We're actually doing that one. Okay, number 10. It says find the exact length of the arc of a circle. Okay, so exact means no decimal. Length of an arc means S. So the formula that we need to write is S equals R theta. And theta has to be in pies. And for us, theta is in pies. Huzzah! Your homework, you might have to convert it. But for the test, it's already going to be pretty. I'm desperate. So we're going to have S equals R 24. Theta times 3 pi over 4. Okay? And we don't want a decimal. So you can either try and reduce from here, if you remember, or we can say 24 times 3 divided by 4. And that gives me 18, right? Yeah, 18, and then we slap the pi on. So the length of that arc on the circle is 18 pi long. And we need a measurement. like meters, millimeters, centimeters. 18 pi, and then centimeters. And it did not say anything about the decimal, so don't write the decimal. All right, number 11. It says use a calculator to approximate. Okay, so first our mode for these first couple of guys needs to be in degrees. But then when we get to these last two down here, since they have a pi in it, you have to be in radians. Okay, let's keep going. So, first let's change our mode. Mode, degrees, good. Second, cosine 32. We're just going to type cosine and then 32. Nothing crazy. Cosine 32. And it says round to 4 decimal places. So let's see here. That fourth spot is the 0. So that 4 next to us says 4 or less, let it rest. So we're just going to let it rest at 0.8480. And in class, we said that you don't have to put that 0 at the back end if you don't want to. All right, let's keep going. For tangent, pretty much the same thing. The tangent button, then 32. And I got 0.624. And then that 8 is in the 4th spot. Yeah, there we go. So we look at the 6, and the 6 says 5 or more, up the score. So we're going to up that score of the 8 to a 9. All right. Cosecant. Cosecant, we have to remember what we wrote down for number 2 or 3, whatever, on the front page, where cosecant is sine upside down. Well, in the calculator, they're different. I think I'm going to go ahead and write up here that in the calculator, CSC is 1 divided by sine. SEC is 1 divided by cosine. Cotangent is 1 divided by tan. So you might want to write this down on your cheat sheet, along with the fact that your mode should be in degrees and eventually in radians. All right, so for this 11, we're going to say 1 divided by sine, and then 32. And we're using sine because CSC is the reciprocal of sine. Reciprocal is like saying 1 divided by. That is the same thing as reciprocal. Okay, so I got 1.887. Then the 0 is in the 4th spot. And the 7 in the 5th spot tells us to round up to a 1. All right, for this next guy, we're still going to type cosine. We're going to type 32. But then we have to go to second apps. For the little degree symbol, then we type 27, then second apps again. For the minute symbol, and then remember Jonah told us to press alpha. I wrote it down correctly today, Jonas, or this time, alpha plus, to get the double tick. So and you might want to write those steps down on your test. On your cheat sheet. Okay, so let's see, we're having cosine 32, second apps, enter, okay. Then 27, second apps, go down to the first tick mark, got it. Then 54. Now we have to press alpha plus. Alpha, plus, parenthesis. And you don't have to close the parentheses. It shouldn't make a difference. Yeah, same thing. Okay, so we get 0.8437, and then the 1 tells us to calm down and stay at that 7. Okay, for this next sucker, now we need to be in radians. I know I'm in radians because there's a pi. You're always in degrees if you have a degree symbol. Anything else, you're in radians. So mode, press enter on radian, and then sine 5 pi divided by 7. Oh, I forgot to tell you how to type the pi. My bad. You press sine, then 5, then second, up, and then divide 7. So we say sine 5 second up divide 7, and we get 0.7818. For this last sucker, we have to keep our mode in radians. We're still going to use that second plus to get the pi, but this time to get cotangent, we're going to type 1 divided by tan, because cotangent is a reciprocal. So 1 divided by tan, 5, then second plus, divide 7. And it doesn't matter if you forget the parentheses on the end, so we're okay. You get negative 0.7975. Okay. Woot woot. All right, let's keep going. Yes, we did cofunctions. Okay, cofunctions. Let's list them out. Sine, the cofunction of sine is cosine. Tangent, the cofunction is cotangent. So we are not doing these reciprocals. This is different. We're doing cofunctions. Okay, and then secant, this reciprocal is cosecant. So cofunctions have a co in front of it, or backwards. So let's see here. This first sucker was sine. The cofunction of sine is cosine, and we don't write the whole word. Okay, cosecant. The cofunction of cosecant is not cosecant, it's just backwards secant. Okay, the cofunction of cotangent is not cotangent, it's just tangent. Okay, now let's write the angles. Let's remember that the angles all add up to 90. And in a minute, we're going to have this pi. So let's remember that 90 is also pi over 2. Okay, so we have to figure out what adds up to 90. Another way to do that is say what subtracts from 90, or what's subtracted. So let's do 90 minus 13, And that's 80, 77, 77 degrees. Hey, there's my cofunction. Cosine 77 degrees. Now let's look at secant. We have 90 minus 54. That's 36 degrees. So secant 36 degrees. Lastly, oh, we got pi's. Oh, darn. We're going to have to do some math. For this guy, we're not going to do 90 minus 4 pi over 7. Why not? Because those are not the same measurements. 90 is in degrees, 4 pi over 7 is in radians. So let's do pi over 2 minus 4 pi over 7. First, we got to get the same denominator. So I'm going to multiply by, the flops. And we get 2 pi. Oh, I did that so wrong. That's so wrong. Okay, I'm supposed to multiply by the flops. I said it, okay, but I didn't write it. So 7 gets multiplied over here on the left, and 2's on the right. So we get 7 pi over 14 minus 4 multiplied 2 is 8 pi over 7 multiplied 2 is 4. Okay, 14. And then when I subtract that, I get negative 7 minus 8 is 1 pi over 14. But we're grown-ups now, so we're just going to put negative pi over 14. Hey, that's the cofunction. And that kind of looks like tan minus pi over 14, so sometimes people put parentheses right here just to show, but you don't have to. All right, last sucker. Find the complement and supplement of each. We did this. Okay, complement adds to 90 or pi over 2. Supplement adds to 180 or pi. So let's see here. This first sucker is in degrees. So our complement, another way to think of adding to 90 is to think backwards with subtraction. So 90 minus 47 is 43 degrees. Hey, that's our complement. Now let's do the supplement. Another way of thinking of adding to 180 is thinking about it backwards, subtracting from 180. 47 subtracted from 180 is 140, 133. Woo! Okay, now let's look at this next sucker, 7 pi over 12. That's not in degrees. So don't use 90 and 180 because it's not the same measurement. We're not in the same unit of measurement. For the complement, instead of subtracting from 90, let's subtract from pi over 2. And then for the supplement, instead of subtracting from 180, we're going to subtract from pi. Okay, let's use our common denominators. For this first guy, I think I'm going to multiply by some 6's. And then on the right, you don't really have to multiply anything, maybe some 1's. Okay, so we get 6 pi over 12 minus 7 pi over 12. Okay, the complement, 6 minus 7, negative 1, pi over 12. But we're grown up, so we're not going to put that negative 1. So our complement is negative pi over 12. It feels weird, but it's okay. It just means this plus that add up to 90. Okay, now let's look at this next guy. This naked pi has a good friend Juan underneath it. Hey! So now that we have that 1 down there, let's multiply by 12s. Yeah. And you can probably see that 7 pi minus, no. Let's write this down again. 12 times pi. 12 times pi. 12 pi over 12 minus, oh, and we don't really have to multiply anything on this right-hand side. 7 pi over 12. Let's see here. 7, 12 minus, that makes 5 pi. Keep the 12. Hey, that's the supplement. All right, and then there's another blank circle at the bottom in case you wanted to practice. For that circle on the front, don't forget that if you trace the x's, you should have the same denominators. So for example, if I trace the x created by this pi over 6 and the other pi over 6, yeah, look, it makes an x from the denominators. So we should make a perfectly symmetrical x when we trace our denominators. If we don't, then either we drew bad, like me just now, or we did some math wrong somewhere. So just make sure that all your denominators lie on the same path of the x. Okay, let's see here. Don't forget, you get a cheat sheet. I would write down pretty much this whole review exactly like you see it. You cannot write down the unit circle, so do not copy this circle on to your cheat sheet. But you can write down these steps. You can write down how you convert. You just cannot straight copy this circle. All right, done.